Ladies and gentlemen, in this lecture you will learn how to use timelines. As I already mentioned previously, the timeline node is a very powerful tool to achieve various goals where timing is important. This time we will use the timeline node to transform a wall into a bridge. Let's get started. Since we already figured out in the previous lecture that our overlap is working, we don't need this string anymore. Delete it. Now drag from Make It a Bridge custom event execution pin and release somewhere nearby. Search for timeline. Click on Add Timeline. Now let's give a meaningful name to the timeline. I think it would be okay if we call it Tilt the Bridge. Now we can double-click on the timeline to open it. Okay, at the moment it's empty. It's our goal to define what needs to happen in this timeline. Let's create a track for vectors. Click on this plus track button. Choose Add Vector Track. Let's give a name to this track. I'll call it Location of the Bridge. Good. We will use this vector track to control the rotation of the wall that will become a bridge by the end of this timeline. Let's quickly return to the level viewport and check out rotation details of the wall. We are interested in the rotation property only. As you can see, it's 0 on X and Y axis and 90 degrees on the Z axis. So, as a starting point in our timeline, we need to make X and Y axis 0 and Z axis should be 90 degrees. Now let's quickly have a look at what rotation properties should be the end result of our timeline. Okay, the rotation on the X-axis should be -90, while everything remains the same on Y and Z axis. Let's undo changes by using keyboard shortcut Ctrl and Z. Now we can return to the timeline. Right-click somewhere on the timeline. Choose Add Key to all curves. Even though you see one key here, these are actually 3 different keys. So the key with the blue line is the Z-axis. The red line is the X-axis, while the green line is the Y-axis. Let's start adjusting the starting point of the Z-axis. At time 0, its value should be 90. X and Y-axis both start with value 0. Now we have to create ending times and values for our axis. Create more keyframes by right-clicking somewhere on the timeline and choosing Add to all curves. Z-axis doesn't change its value. It should remain 90. However, the time should be set to 5 since the length of this timeline is 5. It is stated here. You can change the length of the timeline by adjusting this value. Now I will select Z keyframe and set its time to 5. The X-axis should change its value to -90 and time should be set to 5. This value is the one that actually tilts our wall and makes it a bridge. Finally, the time of the Y-axis should be set to 5, while its value shouldn't change and remain 0. In order to adjust the timeline, so that you see all the keyframes, you can use these 2 buttons. One adjusts horizontally while the other adjusts vertically. Now, let's analyze. These keyframes on the left correspond to the starting position of the wall, so their time starts at 0. I set the Z value to 90 since it's 90 the way it is in our level viewport. Take a look. Those keyframes on the left in the timeline correspond to these values. The keyframes on the right correspond to the values that need to be set. Their times have been set to 5, because the length of the timeline is 5. Since we only wanted to tilt the wall, we set the value to the x-axis to -90. The values of the z-axis and y-axis remain the same. Take a look. So the ending point of the timeline should look like this. As you can see, only the value of the x-axis changed. I know it says -89.99, etc., but we will simply take -90 as a value. That's it. Now we can try it out. Return to the event graph view of the blueprint. Now our goal is to set the world rotation of the wall component. So let's drag it out into the event graph. Now drag from the output pin of the wall reference and search for set world rotation. Hook it up with the execution pin of the timeline. Now, as you can see, the timeline outputs a vector while the set world rotation has a rotator input pin. They are even different in colors. We can't connect these two pins without making a mess. So what do? Well, we can split these output and input pins to a struct. Basically, what we did here is we split the rotator into X, Y, and Z axes. We will do same for the vector output pin of the timeline. Okay, now we can hook everything up. That's it. Don't forget to compile the blueprint and let's test it out. Fantastic. Everything works as it should. The only thing I don't like is the speed of tilting of the wall. Let's make it faster by adjusting endpoint keyframes a bit. Let's return to our Blueprint tab. Now double-click on the Timeline node. Select all 3 endpoint keyframes. Let's set their times to 2.5. To make everything consistent, we can also set the length of the timeline to 2.5. That's it. Let's compile and test it out. Awesome. Now our wall tilts and turns into a bridge much faster. It was set to 5 seconds and now we set it to 2.5. This doubles the speed of tilting. I think we should stop here. Before you continue to the next lecture, make sure you understood everything. Your assignment will be to set the speed of tilting of this wall to 10 seconds. To do this, you need to adjust the length of the timeline as well as timings of the X, Y, and Z axis. Your second assignment is to delete the timeline node we created together and make it from scratch. If you encounter problems, watch this lecture again. If you didn't understand something, find me in the QA section. Otherwise, thanks for watching and I will see you in the next lecture.